Okay guys, so in this video what we're going to do is we're going to look at the proof of de Moivre's theorem, and we're going to be using induction, okay, the method of induction to do that. Now I've skipped a fair few steps here. I'll talk you through them because we've done a lot of induction work, and the maths is going to start from on down here onwards, and I'll talk you through the maths here. So the first thing we know is that de Moivre states that cos theta plus I sine theta to the power of n is equal to cos n theta plus I sine n theta, and we've been using that in complex numbers, okay, and this is defined when n is a natural number, i.e. from 1 onwards. Okay, so we put 1 through as we normally would to test it. If we put 1 through here, we get cos theta plus I sine theta to the power of 1 is equal to, is the same as cos of 1 theta plus I sine 1 theta. You can see the left hand side here is the same as the right hand side, so that's true. As per usual, we're going to assume that pk is now true. So we change all of the n's up here to k's. Okay, this is just the bog standard idea of induction. And then we have to prove pk plus 1. So what we're going to do is wherever you see a k in this one, we're going to replace it with a k plus 1. And then hopefully we can prove the left hand side is equal to the right hand side. And that's where the maths comes in. So you can see here k, replaced with k plus 1, k plus 1, k plus 1 there. Okay, so this is where the maths comes in. So the first thing we're going to do is we're going to get this, we're going to break it up. So we've got k and k plus 1, so that means that we can write this as cos theta plus I sine theta to the power of k, and then multiplied by cos theta plus I sine theta to the power of 1, which is just, there's no need to put that on. Now we know that this here, cos theta plus I sine theta k, this is the same as this, which means that we can rewrite it as cos k theta plus I sine k theta. So we're going to get rid of this. I'm going to replace it with this. So now we have cos k theta plus I sine k theta multiplied by cos of theta plus I sine of theta. Okay, the next thing we're going to do is we're going to multiply out this bracket. So we're going to multiply this by this, this by this, and you know how to do it, lads. Then this, this, and this, and this. So let's do that. So the first one is we've got cos k theta by cos theta plus cos k theta by I sine theta. Then we've got plus I sine k theta by cos theta. And then we have plus I sine k theta by I sine theta. So I'm just going to tidy it up a little bit. So this is going to say cos k theta cos theta. I'm just going to take the I, put it at the front here, guys. So I cos k theta sine theta is exactly the same thing. Plus, again, I'm just going to stick the I at the front. I sine k theta cos theta. And then I've got on this last one here, I've got the I by the I, which gives me an I squared, which means I'm going to get minus 1. So minus, I'm going to get sine k theta by sine of theta. Next thing we're going to do is we're going to get the imaginaries and the reals next to each other. So we have cos k theta cos theta minus sine k theta sine theta plus, and this is the imaginary bit, so I'm going to get them together. I've got cos k theta sine theta plus sine k theta cos theta. So just to show you what I did there, I've got this, I put this, just collect them together, and I've got the i's, and again I just combined them here. Now this is the important bit, this is the bit, or the clever bit. This is where the trig identity comes in, so I'll just put it underneath in red for you. So this here is cos A cos B minus sine A sine B. It's exactly the same on the other side, it's just with the imaginaries. Again, this is cos A sine B plus sine A cos B. Okay, so if we have a look at the first one here, so cos A, this is the same as this angle here, yeah. B, same angle as that there. So cos A cos B minus sine A sine B. And if you look in your tables book, you'll find that is cos A plus B. So this will change. So this whole thing is equal to, just bit there slightly, cos of A plus B. Okay, so that means that we can change that for cos of A plus B. So let's do that. I'll do it in black again. So I've got cos of A, which is k theta, plus B, which is plus theta. Okay, and let's have a look at the next one on the other side. And cos A sine B plus sine A cos B goes to sine of A plus B. So that there, this trig identity goes to sine of A plus B. So we're going to do exactly the same thing. If we do that, we end up with sine, don't get the I in front of it, so sine of A, which is k theta, plus theta. Okay, we can rewrite cos k theta plus theta. Notice, because theta is a common factor, so that's going to be the same as cos of k plus 1. If I take out the theta, I'm going to put it at the end there. You can see here, if I multiply that out, I get k theta plus theta. And it's exactly the same idea because it's the same bracket on the other side. So I sine, and I can take theta out again, k plus 1 theta. And notice that there, guys, is what we wanted on the right hand side. Now we haven't quite finished. You know we have to finish it off using the usual blurb. So we need to finish it off by putting in this final statement. And we're done.